So let's have a brief video on pH. pH, in terms of biological systems, we just view it as the addition of protons, so those are hydrogen ions where the electron's been taken away, or the removal of hydrogen ions. So if you have something where you have a solution where it has tons of hydrogen ions, so you'll have your whatever biological protein of interest. When you have that dumped into this addition of hydrogen solution, this would be also known as acidic solution or low pH. Your protein of interest is going to get little hydrogens added to it. If you have your protein of interest placed into a basic solution, so this is one where this solution is able to remove protons from it. This is also referred to as a high pH solution. This means that protons will be stripped away from this protein. We care about this in terms of biology because let's say that you have a protein that is at normal pH, and pH is just a measurement of how much there is in any particular solution. So pH 7 is just the standard. If it's particularly small, it's acidic. If it's particularly big, it's basic. Keep in mind that there is a inverse relationship between the pH number and actually how concentrated the proton solution is, or protons in solution are. So acidic is actually a lot of protons in the solution. Basic is very few protons in the solution. If you have a protein in a pH of 7, that protein, because of the nature of proteins, has many different amino acids on it. And these amino acids, despite the name of amino acid, actually can exist in both basic and acidic forms. So you can have some that are acids where protons will pop off of them, and you will have some that are bases where protons can be added. That means that if you were to take this protein and dump it into an acidic solution, so at low pH, acidic solution, you could take this protein and take all of those bases before, or what used to be bases, and convert them into basically uncharged spots, or potentially positively charged spots, so in this case, uncharged. So you remove, when you're going to the low pH, all of those basic residues, and by doing this, you are actually going to make the protein more positively charged. And it's positively charged in specific areas. So all the places where there used to be a basic residue, they've lost that either negative or neutral charge. In the case of putting the same protein into a relatively high pH, that is going to negate all of the acid residues in the protein. So this protein goes and is converted into, it still has technically all of the same amino acids, but all of the places that used to be acidic now have had all of those protons stripped away. And so this is going to make the protein overall more negatively charged. And negatively charged in these very specific spots. So all the places where it used to have acidic residues, those acidic residues have been altered because of this high pH. The protons have been stripped away. When it had been in the low pH before, protons had been added on. to cancel the bases. Now in the basic solution, all of the acids are canceled out, they're neutralized. This means that if, as far as biologists are concerned, you start out with a protein that has a certain mix of positives and negatives, depending on whether or not you have it in a low pH solution or a high pH solution, it is going to look different. It's going to behave differently. It's going to either lose positive charge or lose positive charge or gain positive charge.